Welcome to the first breakout of International Data Week. So I'm here with my colleague, Andreas Rauber, and I'm Mark Parsons. And we're going to be talking about some updates to a RDA recommendation that originally came out a decade ago. It was one of the very first working groups within RDA. And it was originally called something like Citation of Dynamic Data. That word citation actually kind of confused people because we're only doing a particular aspect of citation, and I will get into that. So what we are doing is precise, actionable reference to dynamic data and revisions of the recommendations. So the purpose of these recommendations is to enable researchers, data infrastructures to identify and reference the precise data used in an experiment or a study or what have you. The idea is instead of providing static data exports or textual data descriptions of how you subsetted the data, we support a dynamic, query-centric view of data sets. The key is the query. So the idea is to enable unambiguous identification of the precise subset and version of data used, supporting reproducibility. That's really the focus of what we're trying to do. So the goals are to allow us to identify and reference arbitrary views of data. And by arbitrary, we mean, whatever you might happen to think of. From a single record to an entire data set and anything in between in a very precise machine actionable way. And allow us to identify and retrieve that data as it existed at a certain point in time. That's key. Regardless of whether the database is static or dynamic. And then we want this to be stable, consistent across different technologies, so it should persist over time, and then be applicable to all data types. So our solution, as we proposed a decade ago, was to ensure that data is stored in a versioned and time-stamped manner. And that's actually kind of redundant. The really key is timestamp. And be able to identify these data subsets by storing and assigning persistent identifiers to a time-stamped query, which can be then re-executed to reproduce the data that was queried originally. So some background. As I mentioned, the original recommendation was published back in 2015. It was called Data Citation of Evolving Data. And there's that DOI if you want to get to the original one. And it was endorsed by a number of organizations. By the European Commission, it's recognized as a European Commission technical standard. It's acknowledged in an ISO bibliographic reference standard, and the Earth Science Information Partners, a US-based agency which I happen to lead, endorsed it as part of its recommendations on how to cite Earth science data more generally. We had a bunch of example adoptions. I won't read through them. You can see them there. But I think if you're really interested in this review paper, there's the URL at the end, and these slides are available in the shared drive. Goes into great detail and gives a lot of case studies of some of these example adoptions, lessons learned, and then it closes with a frequently asked questions about how people sort of experienced adopting these things. Andy calls it our magnum opus, or our opus magnum, depending on where you put your words. But it is a really nice, comprehensive overview of the recommendation, even though it's the previous version, and the issues you might encounter in adopting the recommendation. But what we're talking about, and so here they are. Here are the original recommendations, but they are now revised. And so that's what I want to talk about now is really the revisions. And then if we want to, we can go dig deeper into the specific recommendations. But we'd also like to hear from you all about your questions, if you've had experiences doing this, that sort of thing. So the starting point for the revision was that it appeared that these core concepts that we embedded in these original 14 recommendations hold across a range of data types. We can't say authoritatively they work for everything, but we have yet to find an exception. validated in a variety of different implementations, both as sort of proof of concepts, but also on the ground, actual real implementations in repositories. What we found, however, is that the intent of our recommendations and some of the phrasing was not clear. So like this title I mentioned earlier, this focus on citation bundles up a bunch of different things. It's about reference, it's about credit, it's about measuring impact. It's a fundamental aspect of sort of scholarly communications. That's not really what we're doing. We are focusing on the precise reference application, which has applications beyond, the scholarly literature, reproducing a workflow, say. So we've focused that more. And we've also then made it clear, we tried to clarify really what has to be done, what you really need to do, versus what you should do, because it can get pretty complex if you have really complex data. And then we also added a short rationale for each recommendation to sort of explain why what the purpose of the recommendation was and give some hints on how to actually implement it. We merged some of the recommendations, resorted them, and now we have an even dozen. So we brought from our 14 recommendations down to 12. But it's important to note that they clarify but do not change the core requirements. The original 14 still stand. The original recommendation is still valid. But we've just clarified and hopefully refined to make it more understandable and adoptable. So yeah, as I say, the original recommendations have not been superseded. And then we focus on precise and identification and reference. We don't talk about credit. There have been some examples of people using these approaches to do sort of fine-grained credit. For example, there was an Australian citizen science program that used this approach to be able to assign credit to particular observations that citizens made. But that's not our intent. Our intent is the precise reference aspect. But people can repurpose things in different ways. And then I think really critically that these have applications beyond citation. It's not just about the scholarly literature. In fact, it's really not about the scholarly literature at all. It's about precise, reproducible reference. And so that would be useful in facilitating automated workflows, tracking precise provenance. I think in this age of AI, understanding the provenance behind data is going to be increasingly critical in terms of building the trust behind these things. So this is an important tool to that. And then finally, and I think this is really the most important, as you dig into the recommendations, you'll find that this is just good data stewardship. There's really nothing radical in here. It's just enabling good data stewardship. So you can do it just for the sake of being good data stewards without necessarily even a use case. But of course, it's better to have real use cases. So the changes in a nutshell. So recommendation 1, we merged recommendations 1 and 2. It basically says you need to put a timestamp and version your data. We merged them because they are kind of redundant. We're using time as a way to version things. A snapshot in time is how you version something. I'll talk a little bit more about that in a minute. You have to store queries. So if people query against your data set and they want to reproduce that, you might want to redo that query. You need to store that. A new recommendation that was implied before but is more explicit now is that might mean that you have to limit your query functionality. Because if your systems change in such a way that you can't reproduce a query, so you might have to constrain how your queries work. And then after you get that query, you put a persistent identifier on it. That doesn't mean you have to put a persistent identifier on every query, but if someone says, I want to save this, I want to do this again, you need to put a persistent identifier on it. You have to timestamp that query, because the time of that query is critical as to being able to reproduce, because it has to capture what the data was like at that time. Consistent sorting, because things might come back differently. This is a little more complicated one, and if we really want to get into it, I'm going to have to pass it to Andy. But the idea is that, so we used to call it stable sorting. Really, the idea is that you do it the same way every time, because sorting of your results might have an impact on how the data are interpreted. Sure, yeah, we can take questions in the middle, but we need to give you a mic.
I mean, if I just want to push on the consistent sorting question. If we're going to cover that later, I'm happy to do that.
Why don't we go all the way through, and then we'll come back. Yeah. Then you'd have to and then result set verification. You need to verify that you got the same results from the second time. And then you have to persist the query. That's the persistent identifier on the query. The query, you have to be able to run the query again in the future. And then citation text. This is where we do sort of concede that this is part of, can be part of scholarly citation. So we encourage, don't require, that you provide, this sort of standard sort of text, Smith and Jones et al., cool data set, spiffy subset ID. Should have a landing page. These are the sort of standard citation guidelines, if you will. This keeps in keeping with sort of like data site guidance and things like that. A new one is data access. You need to be able to re-execute the queries. Again, it was implied, but we made it more explicit. And then perhaps the most challenging one, and the one that really arguably hasn't been fully tested because we're only 10 years in, is that you have to be able to migrate this through systems. We've done some initial studies on this. It seems quite doable, but I think this is perhaps the most challenging aspect of, if you have a complete overhaul of your data system, will you be able to re-execute queries from the past? But if you're thinking about real scientific reproducibility, then you need to take that into consideration as you're doing your tech migration. So here's an example. This is just recommendation one. I'm not going to go through all the recommendations. We can talk about any ones that you want to talk about. But this gives you an example of how it looks now. So preparing the data and query store, you want to prepare your data sources, provide the required infrastructure for it, which is needed for implementing the query based on the approach as follows. If your data is evolving, if your data is not changing, you don't have to worry about this. If your data is evolving and earlier states of the data should be reproducible. Sometimes your data might have changed, but you don't care. It wasn't public. It's a known problem in it. You don't have to make it reproducible. But if it is evolving and you want it to be reproducible, then the infrastructure must version changes to the data, and it further must assign a timestamp of when that change became visible in the system. That's visible in the system, not necessarily, when it happened behind the scenes. So that's recommendation one right there. And then to that we add a rationale. Basically what I just said, if the data changes and earlier data states of the data should be reproducible, then these earlier states must be retained by storing with each update and change to the data set the time when this change becomes visible. So the state of data can be referred at any arbitrary point in time. So if you have an update, an addition, a deletion, a correction, it becomes immediately usable and reproducible. And the key here is that timestamps allow us to refer to the state of data as it existed in the system at any given point in time. Semantic labels like version 2.2, they might be useful for conveying to the public that this is a significant change or something like that. So you can add them if you like, but in and of themselves, they are inadequate. The timestamp is really what's critical. So that's it. There's 11 more recommendations. I think it sort of depends on you, the audience. We're kind of assuming that since this has been out for 10 years that you have some familiarity with this, but we're happy to go into greater detail. And we have another presentation from Andy going into some gory details on a particular implementation, but we only wanted to do that if we had time, because at this point we really just want to open it up to you and hear if you've had experiences doing this, if you have questions, if you'd like to explore any one of the particular recommendations in detail. So I'll throw it out to the online and in-person audience.
Just pausing to allow the online folks.
Not seeing anything.
Great. I'm going to admit that I'm a newbie in terms of this particular spec.
Can you introduce yourself?
Oh, hi, Brian Bolson-Stanton, Macquarie University.
I'm really, really interested in the level of metadata implied in your consistent sorting requirement. So like I have other questions here that I can easily fill time with, but like if you have that consistent sorting requirement that requires the record order to be provided in an order that is not necessarily derivable from the data itself, does that then mean that there is row order as explicit metadata that also has data elements to it? It feels like this is scary.
It is. So this is also why it's not a must recommendation, but it should. And we no, I mean, and the reason is, when do you need it? You need it in situations where the downstream activities depend on the order that data is fed in. So if you want, for example, binary precise, and we can discuss what reproducibility means, but if you want to have binary identical reproducible results of a process, machine learning, whatever, which randomly accesses data from a file and you have your random number seed, then if the order of data that you provided with changes, you can't exactly reproduce it. In those cases where you want to where you want to be able to reproduce the exact order, then you have to provide it in the same sequence. The question is, how can you do it, and what is the cost of doing it? And with all those recommendations, it's ultimately always a trade-off between what purposes do I serve and what is the cost of doing so. Since you were referring to records, so I assume you're talking now relational databases, structured form, what we in our implementations do is, before applying any user-defined sorts, we sort by the primary key of the table. That's a quick sort. And then no matter if the subsequent sorting that the user provides is ambiguous, if two records have identical characteristics according to the sorting criteria, it will always provide the sorting in the same way. So this is, for relational databases, it's actually very cheap to implement. Graph databases, different setting, but then it depends on what your graph database is actually implemented at on the back engine. Because a lot of graph databases also internally have an index structure that then allows to do exactly that kind of sorting. If you have geospatial data or netCDF files, multidimensional data cubes, it really depends on the data operator whether they can identify such a setting. If not, then yes, you would have to add an additional metadata set that stores the sequence. But then I would also, again, try to get that into the data infrastructure in the first place, not as a ex post add-on to it. So really, it is for those settings where the downstream tasks depend on the order. And if you want to enable that, yes, you have to do that.
Thank you.
My name is Carl Tazwell. I'm from California, Brain Health Alliance, nonprofit. We started our nonprofit 20 years ago. So we've been around for at least 2 decades now, and we've been very much dedicated to open science, open access, open everything in all ways possible. While at the same time respecting confidentiality in those situations where we're obligated by law to respect confidentiality, which I'll say that the 2 main applications are healthcare. So for example, we also support clinical trials where we have to maintain the confidentiality of patients. But there are other obvious examples, like we heard about this morning, for protecting confidentiality of indigenous data when necessary to protect the data sovereignty of the indigenous tribes. But there are also other applications that I'd like to bring to everybody's attention. And Unfortunately, we have several ongoing wars around the world. Everybody knows about what's going on in the Mideast. Everybody knows about what goes on in Russia, Ukraine. Some of these countries do have freedom fighters. I think the best and most famous example is Navalny, who was, I also don't think there's any question that Putin facilitated the murder of Navalny in the Russian Gulag. So that's another example where we also have to maintain confidentiality of the freedom fighter who is trying to maintain and exchange data, metadata, information for the sake of fighting for democracy. So with that introduction, I'd like to turn to the audience and ask if you have heard of our work at Brain Health Alliance. We have always called it the Portal Doors Project. It dates back to 2005. If anybody in this audience have heard of the Portal Doors Project, will you please kindly raise your hand? Okay, another name that we have used is
I'm sorry, is there a question about actionable reference to data in here?
Yes, sir.
Okay,
The Portal Doors Project is all about data and metadata.
okay, I'm just waiting for your question.
Okay. Has anybody in this audience heard about the NPDS cyber infrastructure? Then I would pose to this audience, as well as you as authors of your work, how did that happen? Why did that happen? We published our work on the Portal Doors Project in IEEE Transactions Journal in 2007. We also published all of our work on the Portal Doors Project and the NPDS cyber infrastructure in an open access journal called Future Internet in 2010. That precedes your work by at least, I don't know, half a dozen years or so. If we date it back to 2007, our work on data and metadata goes all the way back to 2005. So I would put to the question to this entire audience here, how is it that people are not finding our work online? What are the minimal requirements for doing searches outside the insular confines of a given organization? There are plenty of repositories around the world. Why are they not searched for related work? So I'm now celebrating literally the 50th anniversary of my first publication in 1975. That was 50 years ago. Throughout most of my career, we operated according to the publishing ethics of searching and citing the literature. From the for-profit business perspective, it's called doing your due diligence. Why is it that your work never found and cited my work? And how did that happen? Most importantly, how can we prevent it from happening again in the future? Because it's not fair to me. It's not fair to the historical record of published literature. We literally have now close to 100 papers, posters, and reports on the Portal Doors Project. Why are they unknown to this community here? Where was the failure in doing the search of the various databases and indices online? We have a total breakdown of search to find the published record of historical literature, which then gets either disregarded or literally ghosted. How did that happen?
So that's a deep, complex question. And honestly, it's well beyond the scope of what we were trying to do with this very specific recommendation.
That's what everybody has always said. Everybody has always offered some kind of excuse, disclaimer, which then causes the net result of burying and ghosting our work.
Well, we had no intent of trying to solve the problem of discovery across the scholarly literature. We had no intent of trying to solve the problem of citation metrics and so forth. If it's relevant, send us a reference. Okay, please send us the reference.
It is relevant, and it has been relevant for the past 2 decades.
Okay, I didn't hear anything in what you were talking about. As important it is as how it relates to citing.
I have shared with this community, this audience, if you want open access for open data, for open science, you've got to start doing searches for what is literally open access for 2 decades.
To answer your question from the point of view of a research scholar, I believe that there is such huge exponential data deluge in the world right now. Attention span is the reason your work has not been noted. There is very little attention span, and if you cannot capture the attention of an audience for within 30 seconds, it makes no difference.
I'm sorry,
I
I'm
have a
gonna have to-
question particularly for this session. We have been seeing in the last couple of years that more than papers, it is data sets that are being cited. And I realize in your presentation, Mark, that data sets being cited is becoming more and more important now, even more than publications and papers. But when data sets are cited, who do you think should get the credit? Is it the curator of that data or the community that has made that data accessible, in your personal opinion? Thank you. I'm Geeta Yadav. I work in India. I've been working for the last 20 years.
Okay. I will give you my personal opinion, but then I will also note that I explicitly said that the credit is beyond the scope of this recommendation. This is a specific recommendation on getting precise reference to a subset. Credit is a complex, and part of the reason that we avoided it is because it's a complex human-based thing. We're looking at a technical solution to a technical problem. And in the work I've done with ESIP on our recommendations there, we talk about the concepts of data authors, and we have some discussion of what it means to be a data author. And we also talk about data editors who might be, pulling together and compiling or making some changes to data. We talk about data publishers or releasers or archives, and depending on how you structure your citation, that is one way of crediting things. Another group within ESIP dug in deeper into this credit aspect and realized that scholarly citation is only one type of credit, and that many of the people involved in producing data sets and software and so forth are not recognized through the scholarly process and couldn't care less about citation. They want credit in different ways. Colleagues and I published a paper in EOS, the magazine of the American Geophysical Union, called Credit Where Credit Is Due, that talks about this in more detail. I would also refer you to a session later in the week on the complex citations, something like that, which does focus on credit and how to disaggregate credit from the different, if you have a really complex data set that's pulled in from multiple different sources, how you disaggregate that credit. But that's already probably more than I should have said about that, because this is not, the credit is not the purpose of this recommendation. That is a complex human endeavor. We are not trying to go down that path. Matt.
There we go. Hi, I'm Matt Marinick from the United States National Center for Atmospheric Research. So I'm really going to be interested in the technological evolution part of this. When you get to the point where you're having groups evolving systems, I think that's a really critical question that needs to be resolved here, is how does that track forward? But my question, or maybe a comment, is so my organization, we have several data systems and we have not implemented these specifically. But one of the systems has sort of a similar type of implementation that I think tries to get at the same thing. So my question is really more almost like, is this a semantic distinction that's not important? But the way that they tried to do this is not focus on the query per se, which is what you guys have focused on, but on the question of what data was delivered to the user. So, the users use a system and then, at least in most current systems, they then pull some data down and then do whatever they do. And so what the group at my organization tracks is, which files were delivered and which subsections of files were delivered. and at what point were they delivered. So I think it's a similar idea. It's just not organized around the query per se, but on the delivery. And I don't know if that's a useful distinction or something you've considered in this work.
So basically, it's more how you, so the recommendations focus on data and what is it that the user gets. The question is how you implement that. And traditionally, you would store whatever the list of files that were delivered. The question, storing lists of something becomes quite a complex data management problem in its own right, and it has certain other downsides as well, such as when data changes and you want to get the updated version of it. Now, those files that you delivered are based on some type of query. And when we say query here, we don't just mean whatever SQL queries in relational databases. It can be bounding boxes on images, it can be arbitrary shapes, it can be slice dice operations on cubes, netcdf, data cubes, and so on. And even if you have a file system delivering files, the user selects them via some form of query. Whether that query in the worst case is manually clicking on 17 files out of 500, then it would be a select with those files names being identical. But basically, the term query is just a catch-all for any type of access to data that allows you to filter and select from it. And so basically, it would comply. What we want to discourage from is storing just the result set as a dump. So for example, so one of the settings that we had in, we want to use those identifiers not just for citation and credit giving, but really in a process. So you have whatever automatic analytical processes, you have a query that selects subset of data, you do a study, later on errors are detected in the data, you correct the data, you want to rerun the study. From the list of files from the dump, you cannot get to the current version of it. If you have the query stored, you just re-execute it with the current timestamp, you get the new files. Okay, so those are the upsides, and it's more generic since it applies to all kind of objects, even those that are not file-based. But basically, in principle, it is still the same thing, versioning and timestamp of the data and storing somehow whatever was extracted from it. But not as a dump, which could be huge, but as a small-scale query, which is more compact.
Yeah, thank you.
I have a question. John Grabiel, currently with GoFair US at SDSC. And my question is more about the social adoption aspects of this, what you've experienced and what you hope to experience. And particularly when we have an organization that is interested in doing the right thing, but is not going to appreciate all 13 of the points here. Have you thought about the strategic introduction, which points are the important ones to bring forward first and second, and which points are important to never mention until they're more mature?
I don't know if we've thought about it in that sort of terms. Just off the cuff, I would say timestamp is like number one. The paper that I referenced, it's in Harvard Data Science Review, goes into that into more detail. And definitely the several lessons that came out. One is people found value of implementing even just a subset of the recommendations. And it really depended on their context as to which subset that they chose. But in many cases, they found value not necessarily directly through reproducibility, but it led to an improvement in an interface, or it led to happier users, or it led to a more robust back end. It led to some level of efficiency, something like that. So there was value that was gained just from a general data stewardship standpoint. And there was value in adopting just a subset. Arguably, nobody has actually done number 12 yet. So, although in my group, when we did it, we did at least sort of a policy analysis of what would be necessary to do number 12, which gets me to my next point, that what was clearly the most difficult aspect, I think, for most of the people, most of the organizations that have implemented this, was really the sort of managerial policy type decisions that had to be made to do things. The technical implementation in most cases was relatively straightforward. And then I think the final point was that a number of the implementers, especially the ones that really took it, as far as they could, had some level of seed money. Some of them got RDA adoption grants, which were just a few $1,000s, but it helped. Like in my case, we were able to hire a student that did some of this stuff. In another case, probably one of the most really robust cases was Ocean Networks Canada. They were going through a full overhaul of their system. And so they used this as a guide to their full overhaul of the system. And so it was really impressive what they did, but then they also found it really useful. So that gets to some of your question. I don't think it answered all of it. Did you have any additional comments?
Just an anecdote, basically, because we once, I remember we had a workshop with a data center who was interested in implementing the recommendations, and we had talked to the data curators and so on. They invited us to come over, and they also wanted to bring the technical team on board, but they warned us up front that we should be very careful because they are always worried about any additional workload that comes to them, and this versioning thing might scare them off. So we said, yeah. So we had the workshop, we were discussing the whole thing, we were doing the presentation of versioning and timestamping, and then they were looking anxiously at the two IT guys there and said, what barriers and walls would it build up? They said, it's implemented already. And the reason they said, we have our database and we know that people are making changes constantly. They were so worried that something might just go wrong, overriding data, deleting it, that they had simply activated temporal tables by default. They just never bothered telling anybody because they thought nobody would be interested in that. So sometimes we're worried about the complexity on the wrong end of the scale. And yes, you don't touch an infrastructure lightheartedly, and this is why the policy decision is usually the more critical one, so that you get top-level management support that this is something that is important, that this is an evolution in data management practices, complete traceability, auditability. The technical issues, they're not zero, and yes, you need money or you need the resources to do them, but they are usually manageable. You have people who know how to handle their infrastructure, and adding something to it, depending on the complexity, is doable.
Any other questions? Also online, if you have questions, please type them in. We don't know if you're out there or not. Yeah, go ahead.
I have a second, having built and deployed append-only data stores, the continual reference to timestamps is a bit of PTSD. Can you go to R1 for me, please? My question is, what specification, especially because you also say new data access can rerun on new timestamps. That means that you have multiple different systems playing with the same timestamp across time. And I'm wondering if your spec for timestamps here has any, I've done offline data at append-only data stores and had clocks drift by hours, different systems doing time zone shifts to the system clock and so on and so forth. Mm-hmm. Do you have anything here on the accuracy or provenance of timestamp for purposes of subsequent queries?
So you're talking about distributed query processing, or are we talking data being fed into a central system still?
I'll leave that distinction to you, because I would say that because your queries have to be versioned by timestamp when they're served by, I think, 6, if I remember correctly, then you have your ingestion system dealing with timestamps on ingestion, and your query serving system dealing with timestamps when serving, which means that those two timestamps need to communicate somehow, and that's terrifying.
So it depends really on the granularity of racing conditions. So if you're talking microsecond updates and query processing on a microsecond level, then this is challenging. But basically we had this discussion, and we haven't implemented it in any of the adopters yet, because people brought up those use cases, but we never had anybody who really had it. So the condition that we have is the system that ingests the data does its timestamping. That's the truth when the data becomes visible in the system, and only beyond that time can it be queried. Okay? The query processing system basically issues the query to the data processing system, and that timestamp is returned to the query processing system. That's the usual setup that we got. We had, in theoretical discussions, never implemented, because we didn't have a practical use case, a setting where those systems are completely separate. And in this case, what we would recommend is that the query processing system issues the timestamp of validity and passes it on as part of the query, as you do for a reproduction query. So you first set the timestamp. Now the query should be processed. Take that timestamp and pass that as part of the query. So select everything that was added before that timestamp and deleted after the timestamp and so on. And if you have really extreme racing conditions, you would need to set a time window of a delta of guaranteed updates. But then we're talking real-time systems, which is not the typical application scenario for what we have here.
I mean,
but it would be interesting if anybody has such a setting, and this is basically also the focus of this session here. If any of you has a data center, a data repository, an infrastructure, and would be interested in implementing those, we'd be very interested, first of all, hearing from you, learning where you see challenges that are difficult to address, and we would really like to discuss those in details, because that's the lessons that might work, make it into our next opus magnum.
I mean, definitely let's chat, because like the trick for me is multiple data processors. That if you have devices while offline, our race conditions are hours, not milliseconds. Because the race condition is what happens when clocks diverge. And usually they'll be resynchronized at the start or end of day. So,
okay, for this we had a use case because we don't want to do synchronized clocks because that's horrendously expensive.
Correct.
So what we did, we had one use case of a distributed data center and one central query processing place where the query is then being distributed to the centers. The distributed centers only kept their local time. No synchronized clocks, especially not on a global scale where you forget it. Distributed data centers, local time. Query comes into any query processing center, is distributed to the distributed sites. They process the query, return the results with their execution timestamp, or you could even not return the execution, but the local DOI, because those individual data centers should implement the same recommendations. So they said, I received the query, I processed it, here is the DOI of that subquery, and then basically the central aggregator simply does an aggregation of the result set. And basically it has in various DOIs of the queries that were processed by the partners. And so this is in a completely distributed setting, minimizes the communication over. If one node drops out, still same principles. And that's what I like about the recommendations is that the principles are generic. How you implement them, of course, depends whether you have hours as racing conditions or milliseconds. Yeah.
Cool.
But we think it's doable, and that worked out. That was really a use case that was implemented.
Hi. Sorry, that was very loud. Dave Connell from the Australian Antarctic Data Centre. This is something we've been interested in for a long time, although we haven't really had reason to use it yet because we don't often store a lot of our data dynamically. Most of it's just discrete data sets. So I haven't had a lot of experience with this, so my question might be more beyond the recommendations, but maybe you will know of examples. When somebody makes a search query, I'm surely not every search query would create a citation. There must be sort of a certain point where you sort of say, yep, that's what I want, download it, and then it creates that. Otherwise, you must be filling up your database with endless amounts of citations. Is that right?
So basically, yes. So one of the data centers implemented what they call a shopping basket, cart. So basically, you issue queries, you select. They are stored temporarily for 2 weeks, 2 months, whatever. And then they're discarded, except for those ones that you mark and say, those are the ones that are finally used, or those are the ultimate ones that made it into a study.
Yeah. Okay, that makes sense.
We did something in the Deep Carbon Observatory. We did something similar. It wasn't a shopping basket. There was just a button, save query. So you could play around, explore. And we saw it as more of a case of not necessarily that they wanted to reproduce something or cite something. They just wanted to be able to do the query again sometime in the future. And that's the sort of thing I was talking about, that advantages that came out of, unanticipated advantages came out of implementing the study. The users found that, oh, that's helpful, that I can, redo my query when I come back 3 weeks later and I totally forgot what I did.
But again, the storage overhead of the queries is usually absolutely minimal, because that's usually quite simple lines of things. The question whether you always mint the DOI or whether you first go with an internal identifier and simply store them for users to have available is usually the easier approach. Yeah, yeah. Yeah, because the DOIs are something that you need to manage in the long run. Yeah, so that's why where the actual cost arises in the management of the DOIs, not even the DOI minting costs, because they are negligible. I have a question.
Hi, my name is Faye. I'm from the University of Queensland Library, and we have at university we have a research data manager. It's a system or facility to help researchers to manage their working data as well as publishing data from the facility to our institutional data repository. It's a repository, hosts not just data, but all publications as well. So my question is, you talked about critical time stamping, etc. What's that to do with versioning? Because when we publish data, obviously working data, does it really matter what kind of a thing? Because it's not related to or underpinning a publication. It's less to do with the reproducibility, so to speak. It's when people relate to a research output, a publication, and in that publication they make claims, say such and such and such, whatever, and then other researchers want to reproduce the same results, and they will have access, they want to access the data sets underpinning that research outputs. So that's very critical when you have time stamping or rich metadata, et cetera, or related to software, analysis process, et cetera, et cetera. So when we publish data sets, we say, okay, the published one, version 1, and then people probably make changes to their research outputs along with the data sets underpinning the new sort of a edited research outputs, and that becomes version 2. So your time stamping is related to versioning as well, and how granulate it has to be. Like in our published data record, we just say published date is the year. Obviously, that's too general, but I don't know how often we are yet to track all the information, but we do observe researchers do publish another data record due to various reasons. So that's my question. Versioning, time stamping, which is more important? And
so the scenario that you described was exactly the starting position also for why this whole working group came into being, exactly describing those processes. And what we see is, I mean, we have mechanisms to deal with it with the current infrastructure, which is exactly the process that you described. You know, you get your data somewhere, you do a study, and then you publish the data. What we see happening is that we get away from this discrete data publishing in yearly, quarterly, or monthly intervals. Because if I do studies on basically whatever kind of data that is continuously coming in, or where people find errors, improve the quality of data, correct data, I don't want to wait for another half a year before I have a frozen version of the data set that I can then use in a study. If I have to file a report to management, and we're not just talking researcher, the principles are generic. If I have incoming data, financial data, whatever, I want to publish a report to management for the next PowerPoint presentation on Monday or Tuesday, then I'm using the current data. If then on the next day the data has changed and the PowerPoint is wrong, you know, who's to blame? Was I doing sloppy PowerPoint graphics, or has the data changed? So it's the fact that data is changing more frequently, continuously, is one of the issues. So what we say is, rather than doing a freezing at the time when I publish my PowerPoint, we do it as the data comes in. So continuous versioning the moment the data comes in, which then defines the granularity of the timestamps, which, depending which file systems you have or which database systems you have, can be in the nanoseconds or microseconds. For the versioning, and the publishing later on is, you have huge data sets, researchers use some part of it, or use the entire set. So I publish my 5-page or 10-page paper with 1 terabyte of data. Then there's 2 changes, 2 corrections to the data. And then I publish an update of another 5 terabyte data set, say this is the updated version to that 5-page paper. No, we just update those records. Those records have the new timestamp. So we also want to keep the storage management more easily manageable in the long run. Because, I mean, everybody says storage is cheap. No, it isn't really. Not if you have talking about professionally managed storage volumes in the high volume range.
Can I ask more questions? Yes, so in our systems, I mentioned a research data manager. So when we publish data sets, it's carved in the stone. So we repackage it and put it in another storage. So never touch it. That's why, but if you're constantly changing, and like the other person asked, how do you know which one is underpinning which research output? Like you constantly changing things. I don't know, probably it's a naive question, but
that's exactly the right question, because basically you have this ever-changing data resource where new measurements come in, where people do quality improvements and checks. If a researcher goes to that system and selects a subset for the study, so they pose a query, they select rows, columns, bounding boxes, whatever, and get that data exported either to their own computer or sent to some high-performance computing infrastructure for processing. Then they write their paper. In your system, they would also zip the data and store that into the system, into the repository.
that's only related data sets, not the whole. For example,
whatever is used for the study, that would be packaged and stored into the repository. In our case, we don't package it and store it in a repository. We store the query that was used to selecting the data, which is much smaller. It's just a query string, and the timestamp when the query was run in the system. And so this way, and the researcher gets a DOI, and basically what happens is you won't even notice the difference, because for the reader in the paper, they get a DOI, they click on the DOI, and it takes them to the data set. The fact that in the background a query is being executed is transparent to the user. And basically, so we had discussions initially where people said, yeah, but this is all very complex. You know, reissuing a query, and why, when I want a file, why do I always have to issue a query? It's transparent. Whenever we access a file on any of our computer systems, what the system does, it runs a query across our hard disk. Because our file systems are not continuous block where a file is one continuous stream of data. It's distributed across the storage device. And so every file that we open issues a query to our file system. This pulls together the bit streams from the various parts of the hard disks and pulls it together into a file. So this is a system that we're using continuously.
Okay, but sorry, probably I don't fully understand the system you're describing. For our system, it's not, first of all, for the working data or the whole completion of the data collection, it's not open access. And researchers don't want people to query their whole data collection. That's why we package only those data files underpinning that particular publication, and people can search for that and can, open it, download it, whatever. But as to other data files, even though they generated in the same research project, it's only, one research project can generate many publications. Yep. So they only publish data sets relating to a specific publication. So that's why I'm not sure this query searching thing. I don't understand, probably.
It's exactly the same thing, because you can still decide which queries can be executed and by whom. So there is no difference to that. The user won't notice any difference. This is only on so basically this is the hard work of the technical stuff at the back end running the data infrastructure. On the front end side, the user wouldn't notice any difference at all. They can select the data the same way. The only difference they might notice is that apart from the data, they would also get an identifier if they want to. But that's the only difference that the user would notice. Access, this can work for completely shielded data. And you can decide to publish the fact that this was a query, but the fact that this is a query and how the query looked like also is not required to be part of the published information.
And similarly, and Andy implied this, but you could have, a whole big data set that little chunks come out with publications. Never mind the whole issue of open access there, then that's missing the point. But you could just have, rather than carving out a subset for each publication and putting it with the publication, you just put the query, and so that's all the user gets. They only get the subset that the researcher wanted them to get. They don't get the full collection. So the full collection remains restricted but they only get the piece they get. And so you're not duplicating over and over and over again. You know, researcher A does a subset, and you put that with a publication. Researcher B does a subset that is overlapping with the first subset, and then you have a duplicative thing. You don't have to do that. You're just keeping one set of data that gets queried against, and only the queried data is accessible. You know, because, and like Andy was saying, the user doesn't see that. They're just going to a persistent identifier.
So we had one use case that I remember where we had data, so the data center had data coming in, but it was under an embargo. So they had 3 months for cleaning and preparation where the internal team had access to the data, but nobody in the outside world. So the system was implemented in such a way that a view was defined it was a relational database. A view was defined on the tables that would only select the data that is older than 3 months. And this view was publicly queryable then. So basically, there was no need to release data anymore, but any data that was older than 3 months was assumed to have gone through the cleaning process and would then become visible in the view. And so this access control can be very fine granular on that level because you can define different views for different groups of people that depends on your AI infrastructure, so authentication, authorization, who you give access to which parts of the data. But the nice thing is you can automate those processes then. So it's role-based and it's time-based, what you give access to.
Yeah. Okay. I had another question. So at Pangea, we are mostly doing something like that. So we also have a database query, but we have something like fixed DOIs for specific subsets. So it's basically in the same direction like that. The problem we see with those dynamic data sets is if you have an arbitrary query, you have somehow different DOIs, and then you have the problem of the credit of the data set because you have different ways to refer to the same data, so it makes it harder for something like citation counting of the specific data set. So are you also thinking of something like having one DOI for the whole data set that's always referred to? Because we have, for example, something like, if it is a part of a larger data set, you have something like, you know, those book in citations. So you have something like a specific DOI, and then the whole data set has another
Yes.
Yeah.
The short answer is yes.
Okay.
That this was a discussion that went around a lot, and so that in the case, and it's sort of like, you know, citing a chapter in a book, that you have a DOI for the whole collection, and that is cited. That's typically what gets the credit. You have the author and so forth, but then, you know, subset used is another persistent identifier. So you can have nested, if you will.
And you're also using that type of in notation, so you have that data set.
Wait, I can't hear you.
Yeah. It's on. So the question is, so you also have something like that in citation, like you have with books. It's part of that larger. Okay. Yeah.
Yeah.
Do you have an example of that?
This was already part of the very first set of recommendations published in 2015, where we said we recommend using 2 identifiers, one for the dynamically involving data source, which is like the journal that gets new issues continuously, and then one for a specific paper or a specific subset in that evolving data source.
So there are, I don't remember specifically which ones, but some of the adopters have done this. The biggest missing gap in all of this is publishers. So publishers still don't index just simple data citations. So this is another level for them. But that's partly why we're avoiding the term citation. It's reference. So.
You pretty much answered it. Uwe sort of took that away, so it's fine.
Okay. Any other?
No one else? Okay. You're talking about this sort of thing. I have questions about repository end of life, and specifically recommendation 12, because I'm wondering if new technology can also imply no technology in terms of if you're on, because this came up in conversation with the librarian, if you're storing a reference to the data, then we get into pointer games. And if we are playing these pointer games and the original repository reaches end of life without a good management plan, or even with a good management plan, how do you have a technology migration to end of life rather than technology migration to new and better?
So this isn't something that we really delved into, but other citation recommendations address this, and basically is the idea of a tombstone page. So that the persistent identifier still resolves, but it resolves to a page saying that this data no longer exists, we're sorry. I mean, if a repository totally goes belly up and they can't maintain their PIDs anymore, I mean, PIDs are only as persistent as the humans that maintain them. There's nothing magic about them, at least registered PIDs, not, you know, PIDs based on the content of the data. But, so yeah, just normal persistent identifier practice in that sense.
But the nice thing again is by having the query string or script or whatever is in the background stored as part of it, even if they're not usually revealed on the landing page, that information is still part of the landing page information in the backbone, whether you display it or not, because it's independent of the data center itself as such. So you basically have even more metadata on how it was constructed, which might be interesting, at least understanding what the data very likely looked like. Plus you have, of course, information on the number of records, size, signature, and so on.
So I'm starting to understand why you're storing, why you talk a lot about storing queries. But is it fair to say the system can be equally powerful and valuable, or close to the same, without considering the storage of the queries? That is to say, if the timestamp is maintained in the query itself, the relevant timestamp is maintained in the query itself, then it makes it possible to confidently make queries for any point in time historically, as opposed to relying on a storage system and a resolution system. And it's a lot of extra technology we're adding in order to store a PID for the query.
I'm not sure what I fully understand, but if you say if the timestamp is in the query,
right. So if the user doesn't enter a timestamp in the query, then it's obviously considered internally to be this moment in time, and that becomes the UID.
Yeah.
And then you don't need to worry about the storing or the creating pages or the referencing or things like that. What do you lose if that's the only thing you have is the query and you don't have an associated identifier stored?
No, that's exactly what the system does. So when you issue a query, the system executes the query and stores it with the timestamp of execution, which is usually part of the query actually. Right. So you can put it right into the query. So in SQL, you put it right into the query. We had one implementation that did a JavaScript-based, so Java-based query processing multidimensional data cube slice and dice. There it was added as a separate parameter because they didn't want to change the existing interface. Because changing an existing interface is complex and has implications further down the road. But so that's where the timestamp was stored separately.
I think what John is saying is that if your system is able to reproduce a query that has the timestamp embedded in it, so this range, this time, at this moment, and that's embedded in the query, then you don't necessarily need to store that because you've built it into the system in a sense. Right. But the thing is, you still want to mint a PID for that.
Why? Why isn't the query itself in its own URI the PID transparently?
Well, the URI can be a PID.
Yeah, the URI, yeah, sure.
Okay.
So it doesn't have to be a DOI.
I guess, yeah, and the question is, that's why we use the term PID, because people assume DOI, which then that would not work with a DOI.
Right.
So, but if you had a different sort of persistent identifier.
Yeah. So on the one hand, it reduces the maintainability costs a lot, but you don't get the benefits of having a landing page, having associated metadata, some cool things that come otherwise with an identifier. You can add services with an identifier. Okay, thank you.
We had implementations that used a combination of both. So using internal identifiers, ARCs or any identifier URI for the standard queries, and then the ones that get really published officially that appear in papers or in studies, these ones get a DOI minted because it also helps with aggregation of citation credits and all of that stuff. So it's a different service, but the recommendations do not talk about DOIs. They only refer to some form of persistent identifiers, which URIs fulfill to the level that is needed or required by the recommendations.
All right, thank you. I just want to add one comment at the end, which is I've loved attending these sessions on this topic because I think this is probably the most rigorous or one of the most rigorous products that RDA has ever produced. And I want to give you guys a big heads up.
Publish that.
It's all Andy. It's all Andy. Did you have another question?
Yep. So the term timestamp you are mentioning here doesn't really need to be a timestamp. It just needs to refer to something which is a point in time. So it could also be something like an identifier for a snapshot or whatever when you ever commit to your database. Yeah. So it doesn't, because I'm talking about those people using, for example, Elasticsearch or something like that, so they can have something like a snapshot point in time, and you can refer to that one too.
You can do, I mean, so
depends on your technology.
No, the recommendations discourage that, and the reason is, yes, you can do physical times, you can do even semantic counters, version 1, 2, 3, 4, 5. However, problems start arising when you want to use data across repositories. We are all coming from a really traditional world where you have one repository, one interface, and people interact with that. What we are seeing now is, interdisciplinary work, pulling of data from different databases, having automated data processing pipelines, Jupyter notebooks, you name it. And if then each data center has a different way of identifying it, it's really cumbersome. If I say I ran this notebook and in the provenance, each task step is being executed with a timestamp. And we even have a version where we use Git, but have an interface that accesses Git repositories for source code pulling, not by Git commit number, but by the timestamp. And then the system looks up what is the most recent commit to that timestamp. And then I don't need to worry, whatever the backend system does, because give me the stuff as it was on the 15th of January, 2023, at 7 o'clock, whichever time zone. And that's what the system returns to me. I don't need to worry whether they have counter versions or semantic levels with major and minor releases, which don't hold for data anyway, because what is a major and a minor release for a data? If you change one typo, it produces different numbers, and so the results will differ. So this whole thing, we try to push to the back. Time is, we once had a guy from NASA who said, time is not as trivial as you think, because once you run around the sun, then you got
I wanted to say
that. But yeah.
For example, in the case of the Git repository, you would need to make sure that the person who committed to the Git uses a correctly synchronized clock.
No, no, not at all, not at all.
Okay.
The system where Git is running has a clock, an internal one. It can be off by hours. We don't care, as long as you don't reset the clock.
Yeah, exactly.
Okay, and not at the moment when you actually store it. So the commit message, if you set the clock backwards, then the commit messages might overlap. So yes, we go to UTC and not to local summertime or daylight saving time switches. Should be avoided. But even that, if you have the time zone added to it, it should be.
Okay. I'll pass to you.
Thank you. This is a little bit of a follow-on to John's earlier question about PID types. So you said that you're not specifying the type of PID, which makes sense. But many of your examples are DOIs, not all of them. Do you have any guidance on DOI metadata? Because many of these PIDs have metadata associated with them. So if I'm using these DOIs or I'm querying them separately, do I know it's a query?
So the short answer is no. We don't have any guidance on what kind of metadata.
We don't know is the short answer. But this parent-child thing, so that's where it would come in. Because I think these PIDs that we're talking about have a very narrow purpose. So they would typically be associated with a parent PID which would be like a DOI with the appropriate metadata registered in DataCite or wherever. But like Andy was saying, these could be internal PIDs that are nothing but a number and a location, or a query, as it were.
So for example, since you mentioned whether the query is being part of the metadata and how it's been revealed, this is something we discussed, and the recommendations do not talk about whether you should reveal the query or not, because in many settings, a data infrastructure does not want to release the internal data structure. Plus, the internal data structure is usually quite different from the view that the users get and would only be confusing to a lot of them. And there is no need to know it. But to have the query stored allows you to re-execute and remanage if you do whatever schema migrations or things like that. But no, there is no guidance on you should or you must release the query. On the contrary.
I'll just say that could be a nice follow-on, sort of as if there's another magnum opus that comes out later that uses specific types of PIDs as examples. Like how does the PID metadata sort of play into this whole work?
We definitely want to collect further adoption stories and talk to data centers, especially with challenging settings. So what we're looking for is data centers, this doesn't work for my setting, or at least it's too hard to implement, because that's where we also learn if we do need to adapt the recommendations at some point. So far, it has run almost too smoothly. I'm a researcher. Problems that are solved are boring. No, but I guess there is lots of interesting challenges out there as we start evolving and as we start upgrading our data infrastructures to implement those kind of services. And at some point, they should become a normal, given in the background, like we do backups. Nobody's talking about doing a backup of data storage anymore. Things like that, versioning, tracking changes should be at that level.
Sorry, just one more quick follow-on to that. So in terms of normalizing this whole thing, you mentioned some interaction with ISO or something at some point, Mark, in your slides. Is there thought or movement towards, like, should this be an ISO standard since it seems to work everywhere so far? Should it go in that direction? Would that be beneficial to get more exposure, industry adoption? I don't know.
So industry adoption is definitely, we have been talking to some industry partners who are interested in doing this. We also had one industry partner who said they have implemented that stuff even before we specified them as explicit recommendations, because again, it's not rocket science. We didn't invent anything new there. ISO standardization, I'm not sure what I'm thinking that long
Yeah,
term.
I know I want to go down that path. I mean, I think I'd have to go back. It's referenced in the ISO standard about bibliographic citation. So it is kind of an ISO standard. It's not its own standalone ISO standard, but it's pointed to in an ISO standard. So you're probably more familiar with the ESIP recommendations, and the ESIP recommendations say if you're dealing dynamic data, then use the RDA recommendation. The ISO bibliographic reference standard does something similar.
I'm a big fan of the standards that emerge bottom up from the community. So a lot of the stuff that we see in the ICT world, whatever W3C and so on, are basically community of practice standards where people agree on how to do it. And then you could call them a de facto standard.
I think
so that's
actually,
more the approach that...
it might be more interesting to be like a NISO standard, National Information Standards Organization, I think is what it stands for. It's a US body, but it focuses, and I imagine there's similar bodies in other countries, but it focuses on publishing related standards. So because the biggest problem with any uptake on this, and with data citation writ large, never mind this dynamic reference, is the publishers don't do it right. So, or we could just start ignoring the publishers, which would also be another solution.
More. On the topic of metadata, for your queries, I'm imagining your 5 terabyte data set and imagining that we're going to inevitably need cursors. And so is a cursored traversal of the data, by virtue of running the query specified as a storable query, part of the query that has to be stored, and therefore you have 100,000 queries that you need to store? Or is there a way to have a delimiter on your stored query saying all of the prior of this is metadata about the data, and then post this identifier is metadata about the query, to allow for the technical limit? I'm giving you a headache, I'm so sorry.
No, I'm just trying to understand the question, sorry.
Okay,
So
Cursors is my question. What does your recommendation say about cursor traversal of your data in terms of storing the queries as a reproducible query?
I can't answer that.
Sorry. Do you want me to?
If it
Okay,
just
so
can
I don't know what
example,
cursor.
yeah.
Sorry, a cursor is, I want records 50 to 100, or 101 to 150. It is a way for a computer to get a subset of the data so that you don't hit the database with, please give me a query against 5 terabytes of data. You chunk it up. And so when we're dealing with very large data sets, cursor traversal is one of the most common ways of iterating through data sets, assuming that it's not going to send you a 5 terabyte chunk.
Isn't that just another form of query?
Well, but this is my question, is the fact that we're either limiting query functionality and we're saying you don't get to say, give me rows 50 to 100, you have to download all 5 terabytes of whatever it is, or do we say, okay, there are mechanisms for engaging with the data that are part of the query that are not stored as the formal query that you're storing because it's a technical thing, it's not a specification.
So I would agree with the last statement. So basically what you need to store is whatever you need to re-execute. The cursor is a backend optimization technology that reduces the load on your data processing engine. How that is handled will be completely different from each setup and also from the data infrastructure if you upgrade technology over the years. So I would not see that as part of the query because it has no impact on the semantics. With query functionality, we do exactly that. We say within the query, you should only be allowed to specify those things that are also reproducible across technology changes and across time. So with databases, for example, we discourage computing even the mean or the average over a row, because the way the average is computed depends entirely on the database engine, whether they do a sort by a sort first and then start from the smallest to the largest, or whether they just put it in the way they get. So it should be really limited. The old way of doing data processing is select project for data selection and data processing later on, of course. So really a separation of concerns, and not putting the compute into the database. Of course, databases have become very sophisticated at doing that because it eases the data transfer. And here is also where online data processing systems for real-time transactions may be different from research databases that have a focus on reproducibility and long-term perspective. This is a slightly different purpose, and you can use the same database engine like you do for data warehousing when all the star schemas and snowflake schemas came about and specific database engines came about. But nowadays, they're packaged into the same interface with different optimization engines in the back. And the cursor is such an optimization technology ultimately.
Then I would recommend putting that into your rationale, saying transfer things where you're engaging with the back end rather than engaging with the data should not be formally part of the query.
Yep.
Because otherwise people will see query and go, oh, I'm going to have to store rows 51 through 100. Like, I can see that miscommunication here.
Yep. That's a good point. Hasn't come up yet, but that's a good thing to add, yeah. I mean, something we always also have to push is that this approach is not just limited to relational databases and SQL queries. So we have an example of nested Sparkle queries, Sparkle Star.
Sparkle has limits as well, and it's the same.
With a lot of limits on the time. But we have a solution. We now have a reference implementation if you want to version knowledge graphs or ontologies. Again, which is something I think that everybody who's using ontologies as part of describing the data, if that ontology is changing, it's changing the definition of your data, or at least what you saw as a definition when you pointed at. So these are the kind of the cross-references that we are now trying to approach.
Now it's working, yeah. Thanks. Hi, Gerhard Weiss, University of Queensland. You mentioned before with the time-stamped queries, it's about, the timestamp is about the time at which, the state of the time the data was in. So if you've got disparate time zones and times are not updated properly, and I make my query right now, I query two different systems, I want it always to return the same result as if I did it now, no matter what time is there on the remote systems. So even if one lag's behind 2 hours or whatever, when I rerun it, I want it without this 2 hours extra data. Wouldn't this then make sense to have sort of an identifier of the revision, what the data state is in at the moment, rather than using the timestamp?
No, because revisions, when do they happen? So a revision such as, stable release, alpha release, whatever, quality checked release, those are assertions that we would put towards a timestamp. So anything before that timestamp is, uncleaned, and after that, that's a timestamp from which the data has to be considered quality checked. However, we have seen cases where data that was quality checked and got that assertion found an update later on that is usually then released as a minor update, which again, with data, there is no non-breaking changes to data tuples. The moment you change a number, the computational results will change. So we recommend to really identify data as any state at any given point in time. And the time only has to be local. So if you have two different systems that drift apart, they keep the local timestamps. And that's flexible. It allows new systems to be added without having synchronization across clocks and so on. So it really is designed for resilience and long-term stability rather than just optimizing query processing.
You may have seen the XKCD comic, final copy, really final copy, really final copy. Use this one, no this one, and we all have file systems like that on our computers. So it's trying to avoid that sort of thing.
So for transparency, do you think anyone who is using this should publish how they define their timestamp and query, so people know what they're actually getting back?
So either a simple or a complex answer. So for timestamping, for example, we had lots of discussion of which timestamp to assign. The easiest one is the timestamp when you run the query processing time. Then we had one data set that said, no, they don't want to reveal that because that might point to when a researcher was working, which might even conflict with labor law. So I found it, so basically we then said, okay, you can assign the timestamp of the last global write update to the data source. Or you could go even one step further, the last global write update to any subpart of the data source that was affected by the query, including delete timestamps. So you can increase the granularity if you want. But we haven't had any case where this was really something that we would need to put in practice. So all the implementations that I'm aware of use the query execution timestamp. Releasing the query string was the other information?
Just reproduce it, so it's the transparency of what has actually been done to get the data out. So you know what you have got, and you're trying to actually then go describe what you've obtained.
That usually depends on the data infrastructure. So some of them really make the query explicit, and so you can see the query that was executed. And some researchers love that, because we also had one use case where they said they loved this. The fact that they now got a query system was something they appreciate, because before they had to talk to somebody who was issuing the queries, and that led to a lot of misunderstandings. So now they could see it. Some other data centers do not want to publish the query structure because that would reveal the internal data structure. Also, the column names in databases are usually not as meaningful to the audience as they are for the internal data management people. So there is layers where we basically, in our implementation, we only use views against which queries can be issued, and you can never query the tables directly.
Yeah, I suppose it's, but you're delivering a package, so they don't need to know the ins and outs of the package, but actually knowing what they've got. So you don't have to give them everything, all the ins and outs of your database structure, but it's understanding what they've actually, what that query actually does, so they know what so if they went and randomly did another query that produced something similar and got a different result, they could understand why. So and this is also with the query uniqueness, I guess we should have a slide on that, where we say, okay, we want to issue the same DOI if it's the same query producing the same result set. Okay? Different query producing the same result set gets a different DOI because it's semantically different. Identifying whether two queries are equivalent is impossible.
in the generic case, we know that. But we can do certain mechanisms to improve the likelihood that we catch identical queries. So what we recommend, and most systems do that, they produce the queries programmatically. It's not that the user writes the queries in SQL or Sparkle directly, but they have some interface in most cases. And so the queries will come in a semi-standardized way. But you cannot guarantee that you don't have two identical queries phrased so differently that the system doesn't detect it. But then there is also no harm done, because you still know that they're working on the same data, because the hash key of the result set will match. So I can even identify if two researchers work on the same data, even if they have totally different queries. So there's a few nice benefits that you can get from such representations. And yes, analyzing the query structure also allows you to understand which part of the data was used for which purposes and so on.
And with that, I think we will close. Thank you all for your engagement and your interest. If you would like to know more, please join the working group. And we're always looking for more adoption cases and challenges for the system. Thanks, Ken.
Thank you.